Good evening, sir.
Good evening, Shalini. We will wait for 3 minutes, 3 more minutes, and then start at 16.
Okay.
Okay, so we will start now. I am the TA assigned to this course on Introduction to Environmental Engineering and Sciences, focusing on the fundamental and sustainability concepts. So I am currently doing my PhD from IIT Kharagpur under the supervision of Professor Brijesh Kumar Dubey in Environmental Engineering and Sciences. Today we are going to solve the week 5 assignment questions, and some of these questions may be a bit more complex and a bit more detailed in terms of the answers that are present in various options. So in those particular questions, you might skip them if they seem a bit more difficult to you. Otherwise, we also have few easy and straightforward questions in this assignment as well. So coming on and starting with the first assignment, first question of this assignment, it states, Away asks, like, which one of the following statements is or are correct regarding the mass flow or this mass flux? So you have about 1 minute. You can think about this question and share your answer. So if you want to share any particular answer, you can either discuss that or you can also use the chat box to share your answer.
In my opinion, mass flux is the flow of mass per unit area.
Okay. So you are partly correct in this regard. Mass flux is the flow of mass per unit area, and
Yes.
why this statement is not entirely correct because it is per unit area per unit time. So you have to also relate time with the mass flux. So since per unit time is missing in this particular statement, so that is why it is not exactly correct. And the correct answer is mass flux can be both positive and negative. The reason why this is the correct answer is because in this slide, as you can see, I will zoom it, that when I'm talking about mass flux, I'm basically looking at what is the mass accumulation rate of a particular material into the system. So in this particular formula, you can see that at the same time, some of the mass of any particular material, it is coming in, some may be going out, and then there may be some chemical reactions going on that may generate some mass into the system. So if this positive like mass flux in and the net chemical production, if these two are more than mass flux out, then the answer can be positive. While if more of the mass is flowing out of the system, in those cases, the flux can be negative. So that is
Mhm.
why in here this mass flux can be both positive or negative depending upon the situation. One of the examples where such things happen is a lake. You can see, I will just make a small diagram. Let's say that this is a lake, and I have to determine what is the mass flux into this area and what will be my target. My target will be, let's say, any fertilizer. There are various fertilizers applied in the agricultural fields. They have got various components, various chemicals in them. So I need to determine among them what is the input of one of those chemical into this particular lake. So they can come into this lake via rain, this runoff whenever there is rainfall. So through those runoff, they can come in. At the same time, they can go out if someone is pumping the same lake water and further using it for irrigation. That can be out, like those contaminants or those chemicals can at the same time also go out of the system. While there is a slight possibility that maybe there are some chemical reactions that can also develop some products that we are concerned about. So in those situations, we use this very actively. Mass in, and here we have mass out. So this is one of the instances where this mass flux concept comes into play. And the next question is relatively very easy. You have to just guess or think about the full form of this CMBR. You will have around 30 seconds to think about this. Okay, so in here, the right answer will be, as you can already see that this talks about a reactor. So let's say we have any reactor, BR, that means batch reactor, and CM means completely mixed. So in these particular reactors, there is no continuous flow. I will just show you a drawing of this. So let's say that this is the reactor that we have. This is not a continuous reactor. We have to just fill it with whatever our liquid or effluent is, and we will fill it. This is our reactor, and why it is completely mixed? Because there is a stirrer inside that is always on, and it keeps on mixing all the ingredients that are present, all the chemicals that are present in this reactor. So it keeps on mixing them. So that is why it is called completely mixed batch reactor. The reason why this is called a batch, because you have to fill in the liquid, wait for some time, let that batch be completed, then again you have to fill fresh liquid. So that is why this is a batch reactor. Now this is a batch reactor. For example, let's say that when will it become a continuous reactor? If we have a continuous inflow of liquid from here and an outflow of liquid, whatever is getting mixed, it is getting out from here. So this will turn it into a continuous reactor. So I will put that in. So this is how it can become a continuous reactor. Otherwise, here CMBR is completely mixed batch reactor. This is also explained in this particular slide. And when this becomes a continuous reactor, it is called CSTR, continuous stirred tank reactor. Now next, you have a match of the following questions. I will just, yeah. For this particular one, you can have 2 minutes and you can then share the answer with me. I will increase screen size.
Eh,
A,
in
okay.
my opinion, B part is correct.
Yeah, B is the correct answer. So let me see if there is anything else in the chat box. Nothing, yeah. Yeah, B is the correct answer. So this is just the same that you answered. Now this is a bit uh, more into the topic. This is a more topic specific and in-depth concept. You can attempt this question. In case if you don't know the answer, there is nothing to worry about. This is like more in depth into the environmental science and engineering concepts. This asks that what is the governing equation of a completely mixed batch reactor? In this particular question, uh, the right answer will be this option B. In a continuous mixed, this completely mixed batch reactor, the net change in mass of m is the mass of a particular contaminant or a product, will be the same as that of the reaction. The reason behind this is you can see in here. Let me just zoom it. First thing to note is that in a batch reactor, there's no input into the system, no output into the system. So this change dm by dt means change in mass with respect to time. So that is constant. You can see that there is whatever comes in minus there is that the same amount of the liquid will also go out finally after the resonance time is over. So this thing will be finally equal to the whatever is produced at the end of the reaction. So dm by dt is the change of a mass of a particular component that is taking place inside that batch, that will be equal to the mass of what reaction is occurring. Because both of them are occurring at the same time in a closed vessel and none of the new components is coming in, neither is something going out. So that is why both of them are same. So this is a bit more complex. If you don't understand it, it is okay. Now the second question is, which of the following is or are correct? It is a simpler question and a more basic one. You can attempt this one.
Nowadays, Earth's surface would be cooler than today. Without atmosphere, it would be hotter than today. The temperature of Earth's surface does not depend on the atmosphere, but on these. In my opinion, B answer is correct.
Answer B. Without Earth's atmosphere, Earth's surface would be hotter than today. Okay. So I will just explain this. Like I have a figure already in here. So in here you can see that why is Earth's surface basically getting hotter and hotter? Why we say that there is global warming, this and that. So with a figure we can draw this. So let's say this is Earth and we have a layer of atmosphere. Let's say the troposphere. It's like this, some layer over Earth. So what happens that if there is a layer here, let's say of greenhouse gases, carbon dioxide and all that is present currently. So the rays of the sun, the infrared radiations, they will come in. But unfortunately, while going back after getting reflected, they can't go back because this layer doesn't allow this infrared radiations to all of them to pass out. Most of the radiations they stay into the reactor and get reflected back from here into the earth. So they get reflected back. So this particular layer, it traps the heat. It is not letting this infrared radiation go out. Whenever it gets reflected from Earth's surface, it is obstructed by this tropospheric, the layer of greenhouse gases, CO2 and other gases, and it gets reflected back into the atmosphere. So that is why Earth will be hotter, like it is hotter due to our atmosphere, and if there is no atmosphere, then this layer would not be there. Whatever it is coming to the Earth, whatever infrared rays are, they will just be reflected back into the space. So there is no trapping of heat in here. So that is why option A would be the correct one. That without Earth's atmosphere, the surface would be hotter. Sorry, would be cooler than what it is today. So that will be the correct answer.
A is the correct answer.
Yeah. In here also it is a easier one that you can see the rays are coming in and the same is going out because there is no atmosphere to trap this outgoing infrared rays. Now this is another question, like out of these which is not a greenhouse gas?
Argon.
Yeah, argon is the correct answer. Rest all of them are greenhouse gases. Now this is again a bit more detailed depth question of environmental engineering and sciences. A bit more mathematical one, like which is the correct formula for first order reaction kinetics, and CSTR in here it is completely stirred tank reactor. Sorry, continuously stirred tank reactor, not completely. So I will just share the derivation with you in the next slide. You can see that in this particular continuously stirred tank reactor, it is a first order reaction and its formula will be like this. C out means concentration of the of any component or any compound that is going out of a reactor. It will be C naught, which is the initial concentration, divided by this particular formula. K is into V is the volume and Q is the flow rate. So now coming on to question number 8, which is a bit more simpler question. Out of these four, which one truly depicts the relationship between length and width
The
in a plug flow reactor?
flowing is too good and plug for it. B part.
Yeah, absolutely true. B is the correct answer. Then this is also easy numerical. We have to calculate HRT, hydraulic retention time, of a continuously stirred tank reactor whose volume is 300 meter cube and the hydraulic loading is 25 meter cube per day. Hydraulic loading means whatever liquid or effluent or water, wastewater is coming into the reactor at a rate of 25 meter cube per day. It has a volume of 300 meter cube. So what will be the hydraulic retention time? Time for which that effluent will stay into in the reactor.
Charity of a CSTR volume 300 to operating at a hardware loading 25 grams per day. 2 hours, 6 days, 6 hours. A part.
Yeah, is the correct answer. And you must have already seen that it is 300 divided by 25 is equal to 12 days. Then this is the same question that we begin with. This is what is the unit of mass flux density. Mass flux density you have to determine like at what rate a certain mass, whose unit is gram, it is flowing from a system.
Second coordinate is square.
Now let's say there is a mass of a material whose mass is in grams. Unit will be gram. This is a surface area across which, a cross-sectional area across which this mass of material it is flowing. So the unit of this area, it is the same as a normal area, which is meter square. Meter square. And now you have to also mention the flux rate. So it will be, you have to kind of measure what is the flow rate of a material through this particular cross section. So it will be gram of a particular material flowing per unit area, which will be meter square, and per second. So this will be the correct answer, gram per second per meter square. This is the same thing, mass per unit time per unit length, per unit square length, because it is basically the area. Then now whatever questions, question number 11 to 15, these 5 questions, they will be multiple correct options. They can be for these questions, and this is the first one out of them. You have to find out which of these options are correct.
I think to be C.
C, yeah, C is one of the correct answers, absolutely. And another is A option, because C and B are, the name itself says, completely mixed batch reactor. So it therefore operates at batch mode. This is one obvious correct answer, and another one is C. Okay. Then again, this question number 12 also has more than one correct answer.
In my opinion, D.
Yeah, D is one of the correct answers, because a control volume has its boundaries, has some demarcated boundaries. Like you can see that this is a flowing river. In here, if I want to have a control volume, let's say that this is a control volume. This particular area between these two lines, this is a control volume, and you can see that now rest of the option are, is one of them, it is a spatial region, or is it a temporal region. When I'm talking about temporal region, it means that it is changing with time. But this thing, whenever I am fixing a control volume, the location of the area of that volume, that is fixed. So it is a spatial region, it is not a temporal region. We are not relating this control volume with a particular time, we are relating it with a particular area. So this is more area specific. So we have C and D, these two are the correct options.
C and D.
Then in 13 also, you can go through it.
The answer to time in CSTR, reactant temperature in CMBL, the time PR, answer to variable time assist. In my opinion, A and B both.
A and B, okay. So A is reactant concentration inside the reactor varies with time in a continuously stirred reactor. And B's reactant concentration inside the reactor varies with time in completely mixed batch reactor. So A is not exactly correct, rather B is the one of the correct answers, because whenever, like, I will show you, like, let's say if this would have been a batch reactor, I only have these components.
Yes,
There is nothing like this. This is not there. It is a batch reactor. So whatever is the concentration of a particular chemical in this reactor, it will continuously react with something and its concentration will continuously change. So one thing is pretty clear, that is, in a batch reactor, the concentration of a particular chemical, it can go off change, keep on changing. Let's say in the beginning we have a sewage, and in a sewage there is high organic matter. So if I am treating it in a batch reactor, with the passage of time, the amount of organics in it, it will keep on reducing, because as it reacts, it will release CO2. If it is an anaerobic system, it may release methane. So that carbon which is present in this reactor, in this sewage, it will keep on going out from the system. So its main concentration in this liquid system, it will keep on decreasing. So that is why in this particular question, which one was that? Yeah, option B is one of the correct answers. Then in option C, we have that the reactant concentration inside a reactor varies with time. And then option D is reactant concentration inside the reactor does not vary with time in CSTR. So option D is one of the correct options. And then option C is that reactant concentration inside the reactor varies with time in a plug flow reactor. That is also true. Reason being that in a plug flow reactor, it is like this basically. So let's say I am measuring something, a mass of liquid which is here, it is flowing continuously from here to here. So its mass will keep on, so the concentration of that chemical which is present at this particular time, it is continuously reacting. So that by the time it reaches out of this system, plug flow reactor, there will be nothing or reduced concentration in it. So that is why the reactant concentration inside the reactor varies with time in PFR. So this B, C, and D, these are the correct answers. Now coming to question number 14.
in my opinion, A and B.
In which of the following options related to energy balance? The total energy of an isolated system is constant. It is correct. Option is true. And then change in internal energy of a closed system is equal to the work done. This is a bit tricky. This is not exactly true. Rather, this one will be a better statement that the change of internal energy in the closed system will be the amount of heat that is applied to the system minus the work done by the system. When I am supplying heat, it is gaining energy, while minus the work done is when it is doing work, it is losing energy. So the change in internal energy will be this amount of heat gain minus the work done. So this option A and option C, these are the correct options.
Okay.
And now the last question, question number 15. So in here the correct option will be one of the statement is true, that is option A, that advective transport is related to the flow velocity. Advective transport is a kind of transport when something moves along with the flow. So that is why if the flow velocity is more, the advective transport will be quicker. The next correct option will be option C, where it is stating that mechanical dispersion is related to the randomness of fluid molecules. Now, mechanical dispersion, let's say that there is a sand grain or something inside in a liquid, and if the molecules are moving very randomly, so it is getting more properly mixed. So that is why more mechanical dispersion occurs when the randomness of the fluid molecules it is more. Then turbulent diffusion is due to the random fluctuation in advective velocity. So that is also true. Turbulent means there is no sense in that particular diffusion. It is diffusing very rapidly and not in a particular way. And it is only possible when there is a random fluctuation in the advective velocity. So option A, C and D, these are the correct options. And in here, the definition of turbulent dispersion also it states that basically turbulent diffusion is due to random fluctuation in advective velocity. In here, you can see this figure also. This is then there is a random fluctuation in the velocities, direction of the velocities. So that is why it leads to turbulent dispersion. While in this particular figure, you can see that there is nothing, no randomness. It is a homogeneous flow. Everything is flowing in the same direction. So that is why option A, B, and D. I think B is not the correct option. Yeah, A, C, and D. These are the correct, not B. A, C, and D are the correct options. So these were the questions that we discussed today. If you have any doubt or you want to go through any particular question out of these, you can share that with us. Otherwise, this will be um, the assignment questions for week 5.
One question regarding the assignment is from my side, and sir, I want your guidance regarding it.
Yeah.
I have raised the question in the question forum also, but I didn't get any reply from the institute.
Okay.
The question is very simple. Water supply for the plant having the population 1,50,000.
Just let me write it down. I will write down the question at the same time. I will share my screen also so that you can verify.
Okay.
Okay. Yeah. Please go ahead. Yes. Please dictate the query.
Water supply plant is designed for the population 1,50,000.
Okay.
Estimate the total draft required to be treated when the average consumption is 250 LPCD.
Total consumption is
250 LPCD.
yeah
And the uh, fire demand is given 71.8 MLD.
MLD. Okay.
In my opinion, this question seems to be very simple. Uh, I can just keep the 1,50,000 multiplied by the average consumption per person to 250 LPCD,
Wait.
and the
Just
fire demand can
can
be
you
added.
can you just repeat that again?
My just calculation towards this question is that,
Hmm.
as the question seems to be very simple,
Yeah.
and the estimated total draft for the plant, that is the population multiplied by the average consumption per person,
Yeah.
250 multiplied by 1,50,000, and the fire demand is to be added into it.
Yes.
And in this way, whatever the options have been given for this question, this result doesn't match to them.
Okay. Can you share what is the correct answer? Next.
Uh, According to my calculation, the correct answer is 109.3 MLD.
Okay. And what have they? What does the question says? Is the correct answer?
Question says that the
Like, what is the answer, correct answer in the assignment or question that is given as
uh,
compared to
they,
yours?
they have given four options. One is 131.9 and others are lesser than 100. Exact figure I don't remember.
Okay. So let's see.
I have
This is
raised the question forum, but the answer I couldn't get for that.
so the population is 15, 1,50,000. Total consumption is this, and fire demand is this. So okay, 1,50,000. And is was this a assignment question or something in of a test or something?
No, no, this is assignment question.
Okay. So
And the
this particular its value come out as 109.3 MLT.
uh,
Just give me a
according to
moment.
my calculation, it comes to be 109.3, and the options which have been given 139.3, 101.3, 67.5, 120.5. In
Okay.
this way. And I have requested the institute to be reviewed regarding the this question.
Is this one of the options 92.9?
Uh, no, no option. The
Okay,
options are 139.3, 101.3, 67.5, and 120.5.
120. Okay, then I will check this question with the team and then get back to you maybe in the next class.
Till that time, the time will be over, and I have to reply whether it is right or wrong. But in my opinion, the question which has been given,
Okay,
the
so let
options are
me
wrong.
see the. So you have this question already posted in the forum, right? Then I will look at it and answer it there.
But tomorrow is the last date for the for to sending the reply.
So, but is this question from this course?
Is someone trying to say anything?
Are you able to hear me?
Yeah, you are not audible clearly, like your voice is not clear.
1 second.
Yeah, it's better now. Yeah,
It's better now.
yeah,
The speaker is on. Everything is on. 1 second. Now, is it okay now?
yeah, it's a bit better.
Mm, So, is it audible? Is this?
Yeah, yeah,
I think this question belongs
it's
to
a.
another course.
Sorry, can you write it in chat box if possible?
Yeah.
Posted on the description forum as well. Okay, so this electronics waste management, this is being taken care of by different team. So I will convey the message there. Electronics waste management, fine. So I will convey the message to that team. And Shamaji, your question, maybe I will just give me some time. I will try to talk with others and get back to you.
Yes, yes. But my request is today I want the guidance from yourself.
Yeah, actually, this particular question it asks that estimated total draft to be treated. Like
Yes,
this particular demand, what you are writing 109.3, this is the water demand. And when
yes.
I am talking about total draft to be treated, it is like of that total water demand, how much will be going to the sewage plant that is to be treated. So it is will definitely be less than 109.3.
It will be less than 109.3.
Yeah, it will be most probably it will be option 67 because not all of the water that is supplied it goes back to the sewage treatment plant. Some of it is used for, let's say, watering your gardens, or it gets leaked out of the system. So when I multiply this 100 and this 1,50,000 into this LPCD, the amount of water that you are getting, it is the water demand by the public, and fire is
Yes,
also the total water supply that is required. It is the total water to be supplied, but this is asking what is the total water that will be treated. So these two are different. So it will be definitely less than 109.3.
I see. But then what factor we have to just imply in it? Total demand of the public, whatever for the town is required, that
Like
we
that,
have to.
like there are different factors for that. Sometimes it is 85% of the water that is supplied it reaches the this sewage treatment plant. Otherwise, there must be some particular factor that you have been shared with during the classes. So that can be multiplied with 109.3.
But one thing more I would like to ask that when the demand of the town that comes to be 109.3 MLD
Yeah.
and total draft required to be treated total and in a common sense my assumption is that what water treatment is required when the demand is already there for 109.3 MLD
Hmm.
and we cannot treat the lesser water for the demand of the town.
Yeah, we should. Okay, so you are taking it like that. I am thinking that this can be total draft to be treated. So I was thinking that this can be either the wastewater that should be treated, or in that way, if you are thinking of the water that is to be treated, yeah, in that way it should be
But
more than.
but regarding the wastewater, nothing has been mentioned in the question and nothing has been indicated there.
Okay, then 109.3. Yeah, in that way, the correct answer will be 125 because we take a factor of safety of 1.15. So we have to multiply 109.3 by 1.15. That will be the total drinking water that should be treated.
But your solution that also doesn't is it is not there in the option.
So you yourself said that 125 is one of the options.
No. 139.3, 101.3, 67.5, and 120.5.
Then 120.5 will be the closest option. So I think that will be the one. But you have to multiply this total 109.3 with a particular factor of safety. Then you will reach
Oh,
this.
your opinion is a factor of safety is to be applied
Yeah.
in that. I
Yes.
see. Okay, then it is your guidance, and I give respect to it, and most welcome for that one. And one question is also I
Yeah.
would like to. What will be the pattern of examination which is going to be held on 29th and 30th of April for this particular course regarding which we are having discussion at present?
Yeah. You
That has not been told till now.
have you mailed this to the NPTEL team who are organizing this?
Not there yet.
Yeah, you actually I don't know about the format of questions because this is not that is not prepared by me. So they will be the at better position to answer that.
I see.
Most probably it should be this MCQ type questions only because you have been solving those kind of questions. So it
I
should be
see.
like that, but it is better that you write to NPTEL, you mail to them, and they can clarify that out.
But I see the NPTEL team doesn't reply for the question forum also. There are so many question forum. There were near about 20 questions are there pending there, but the team I couldn't see any reply. I don't
Okay,
think
just
what
wait a
is the
minute.
thing.
भाई NPTEL में क्या MCQ questions होता है क्या फाइनल एग्जाम में? हाँ? Okay. Yeah, it is MCQ based questions will be there.
MCQ based
Hmm.
questions. Okay. Okay. My questions were only these two, and that I have raised you, and
Okay.
I'm happy that you have guided for the both questions in a
Welcome.
better manner.
Thank you.
Thank you very much for that.
Yeah.
So you're able to hear me?
Yes, you are audible.
Okay. I have sent a few questions on the discussion forum.
Is it related to this particular course or something else?
This course.
Yeah, you can. Yes, you can share your.
Mm, one question is the question assignment 5, carbon sinks, question 6, I think, on carbon sinks, which is the biggest carbon sink, the largest carbon sink.
Okay, so what are the options?
The options are given as soil, ocean, plants, and rocks.
Yeah, so ocean will be the correct answer.
Ocean will be the correct answer. But in the notes it says lithosphere. So because the lithosphere contains a rock material, I thought the rocks um, might
Okay.
be the answer.
So have they shared with you the correct answers?
In the lecture notes, lithosphere is given as the largest carbon sink, the first largest, and the ocean
Okay.
is given as the second largest.
Okay, then so lithosphere will be the one. Actually, there is a in various literatures people say that ocean is the largest thing, and in some lithosphere they are saying. So both
Mm.
of either of them can be. So if it is lithosphere, that is how the literature goes, the text material, then you should follow that.
But I got wrong answer result. The correct answer is given as ocean.
Okay.
So
Actually, actually,
I
if
wrote
you
option B and I got wrong answer.
okay, but if you Google it, I think ocean is coming as the largest carbon sink. So that is why maybe there is some mistake
Yes,
in there.
yes, sir.
Yeah.
Just 1 minute on this question. The institute has given the correct reply of the ocean,
Hmm.
and the Google also tell is as ocean.
Yeah.
The Google says ocean.
Yeah.
Several articles say ocean, but there are also articles which say lithosphere because of
Okay.
the
So
rock
hmm,
content.
I think that we this solution went with ocean. Still, I will communicate this point to the team who is handling this thing. I will let them know to make this correction or make it more clear in the
But
next
then in
set
that
of questions.
soil is also part of lithosphere, right?
Yeah.
So I think the question itself needs to be reworked.
Yeah. That should be more clear. The question, like what should be the correct answer. Is there any other? You were saying that there are a few other queries.
Yeah. One is regarding I've posted a few on the discussion forum. I'm You're able to view them. One is on this 10% energy rule.
Yeah. Please go ahead.
The 10% energy rule. It is given for the natural process, right?
Yeah.
So I would imagine for the synthetic process, it should be less than 10%.
No, it is like that. We don't usually see. Like if we have
Mm,
a some lignocellulosic feedstock, let's say rice husk or something like that, and we try
mm,
to convert it into a material like coal like material that has a higher fuel value when it is combusted. So in there, we don't usually see that if let's say that the feedstock has 100 units of the initial rice husk has 100 units of energy, the
mm,
next pole like product that is formed, it will have 10 units of energy. It is not like that.
mm.
It is rather that it can go up to as 60 units or maybe 40. So this 10% rule, it is basically the natural thing that is happening. It is for that.
No, what I'm trying to say, if you look into the sequence of processes, anyway, it uses energy and mass at every step, right?
Yes, so 10% rule basically it says that if in nature there is 100 units of energy coming, the next at next level it will take only 10%, then the next level will take only 1%, then 0.1%.
10%.
Yeah,
So
then
I
point
would
1.
imagine for a synthetic sequence of process, let's say what I'm trying to say is if I do some recycling of a synthetic product,
Hmm.
so I spend energy and resources on recycling a synthetic product, and
Yeah,
then yeah, at some point I'll have to recycle the synthetic
correct.
recycled product again. So that might turn out to be even more energy consuming, even more
So if
energy
you look at
dissipating.
it like comprehensively, like I thought you were talking about the energy that unit has. So if you
Hmm.
think of that unit, then yes, it is converting to 60-70% of that energy is enhanced. And if you try to look at it like overall how much energy is put into the system and how much is then back generated, then you have to do the entire mass and energy balance. Then
Hmm.
maybe there that can somewhere be either this 10% or lower than that, but that will be then you have to consider the entire system. What is the energy you are giving, what is generated. Otherwise, let's say that we have 100 grams of a particular feedstock, we have
Hmm.
carbonized it, it will become, let's say, 60 grams or 40 grams, but that will be more energy rich if I am just thinking of a particular product. But then if I
Hmm.
take into account of the energy that is supplied into the system to treat that and carbonize it, yes, then we have to see whether this is totally like a net increase or it is somewhere similar to 10%. So that we
Hmm.
need to take into account.
Hmm. Um, so what I'm trying to say is, let's say if I recycle earthen pots, for example, as a case study. So can you hear me?
Yeah, you are audible. Please
So
go
as
ahead.
a first step, I'm just comparing recycling earthen pots with concrete pots. I'm talking about the flower pots.
Okay.
You get as earthen pots, concrete flower pots, and then the grow bags. So I want to know which overall is better to use. So if I use this 10% energy rule, I would imagine probably the earthen flower pot is more favorable than using grow bags or concrete flower pots. Because at some point I'll have to spend more energy. In the second, if I see the compounded dissipation of energy, then if I'll have to end up at some point I'll have to recycle all this.
Okay. I got your point. But if we specifically look into the definition of 10% energy rule, it is
Mm,
particularly related to the biomass. Now, if I am talking about plastic, if I am talking about earthen clay pot, they are not included in the biomass. So this 10% energy rule, it will be, it may be somewhat similar, but it can't be clubbed into this 10% rule because that
no, what I
specifically caters to
imagine
bio.
is, yeah, because synthetic processes are a lot more inefficient than natural processes.
Yeah,
They are
so
like
you can say that
really
overall,
a lot. So if
overall
I
it will
look
be
at the
more energy
compounded
intensive.
energy dissipation,
Yeah,
then
it will be
recycled products may prove to be very costly.
recycled products will be costly if it is much if the more the sophistication of the recycling, the more cost is getting incurred. The reason being,
Recycled products will be even more costly.
it actually depends. Like if I talk about the availability, the like this
Yes.
is
I now read about plastic bottles between converted into t-shirts
yeah, usually it is
and
costly because the recycling market is not that much, so that then demand and
at some point I'll have to end up recycling the recycled products also.
yeah.
Shirts and the plastic bags into shoes and everything. But I may now think, oh, these are all recycled, and I'm doing a good thing by purchasing these. But am I being correct?
Yeah, that you have to look how exactly it is being
At
recycled.
some point, I'll have to spend more energy trying to recycle Or if I look at the compounded energy dissipation, then I'm better off buying a product which is more natural.
Yeah, it will be true in some instances, but it may not be true at all. The reason being, if I talk about the mobile or this lithium ion batteries, in these cases, you need those rare earth metals. So
Mm,
if you have got a huge ample of e-waste or something like that, it may be,
mm,
if there is a proper supply chain, it may be easier to get it recycled or get it
mm.
from those particular waste streams rather than again mining of those virgin metals. So these
In
can
both
be,
cases, it is justified actually.
yeah. So it
It's
is
justified.
case wise.
But
Like we have to look what we are.
these kind of cases where we have other options.
Yeah, it depends
So
on from case to
what I
case.
find out is the grow bags is more popular. The concrete pots are more popular,
Yeah.
and so because people believe they are more environmentally.
Yeah, that is not exactly true. You said it correctly. Like we have to look how
uh,
that is recycled. So to,
I can understand it. Technology-based products like the mobile phone, we'll have to, even if it means spending more energy, it is justified there.
okay. So for plastic bags, we are saying that if we recycle these plastic bags rather than,
Into shoes, and at some point, I'll have to recycle these shoes also. And they also have more chances of becoming microplastics at one stage.
yeah. So the challenge in recycling shoes and getting all this is that like
And clothes, that might prove to be even more draining
costly.
on the environment than because our intentions are good today.
So that needs like all these things. It also depends on the social behavior. Like
I areas where recycling itself might become very costly on the environment.
especially in case of these shoes which are difficult to collect, like whenever you see in any process this transportation phase, it takes a huge toll on the overall cost. So if we are talking about the smaller units like shoes, they have to be collected from individual households. If that's the case, then and we are using some motorized vehicle, then it doesn't make sense to recycle shoes in that way because it will be much more costlier than the normal new shoes. So that is why we have to be
Already
very
an
clear.
enormous amount of energy and resources have been spent in recycling plastic bags into shoes in the first place.
Yeah, that I need to see like what studies have said. I'm
So
not exactly.
I'm just extending the 10% energy rule. So the dissipation might be even more.
Yeah, because one thing is constant, like whatever energy a particular level, a particular product has, if you refine it to something else and you look into the overall energy, that balance concept, then it will have lower energy. So you can never
So
have
in
something
these
of higher
cases,
energy.
you have natural options.
Yeah.
In clothes, you have natural material, and similarly in shoes, you have canvas shoes. Maybe we can give recommendations to people that canvas shoes made of cloth material can be used, and you know you can occasionally use
Yeah, these things
synthetic.
are to be studied for a long time. I don't think that we can just, if it something appears environment friendly, it is not wise to just straight away say that is environment friendly. In fact, those synthetic shoes, they can be more environment friendly in the long run because they may be more sturdy or things like that. So
Yeah,
you have
but
to take the time
I'll
frame also.
at some point I'll have to think about recycling them.
Yeah, so recycling is like if you want to bring the concept of recycling, that is entirely different. Like we have to set up a supply chain. There should be a market established that will also dictate the cost. So we have to
But
see environmentally
does,
and economically.
even if I don't take
Sorry.
all this into consideration, just taking into the energy costs,
Hmm.
because there is heat dissipation, right, in every
Yeah.
process. So that can lead to more global warming. What I'm trying to say is it might lead to more global warming itself.
Yeah, heat dissipation is there, but what industries do is that they try to recover as much as possible from that heat. Like a few months back, we visited one of the steel production plants. There, whatever heat is generated, they try to recycle as much as possible out of that heat and use it in various pre-treatment processes. So industries are also very cautious about it because they want to save the money, and so that is why they find out ways to recycle or again uh, just tap into that extra heat that is lost.
Hmm.
Like those blast furnaces, I think we call them, where coal and all are put. So in there, a lot of heat is generated. So whatever, when that's melted iron, it is coming out of there, so it emits a lot of heat into the this conveyor belts and all. So then they carefully take it through various processes so that that particular heat can be again used for like preheating something like that. So that is
Hmm.
how they use it.
Hmm. Okay. Why I ask this, because we use even paint cans, to grow plants. We recycle them by.
Yeah, we reuse them kind of.
But now I'm wondering whether I'm doing a good thing.
No,
Yeah, we do purchase,
reusing is better, but recycling we have to see, like you rightly said,
because
we have to.
even that becomes brittle. I'm now finding they're all becoming brittle after a while.
Hmm. So it's still
Mm.
better than using it number of times than just throwing it away
So
after saying.
our intentions may be good, but it may have its repercussions.
Yeah,
So we want to have a proper feedback as to whether which one is better for the second level of recycling.
and better in the sense like how?
If I consider this example, let me take, because it has all the features, like the earthen flower pot versus the concrete flower pot versus the grow bag versus a paint can with punched holes.
Okay.
So if I compare all of them and then find all these, if I say, I'm thinking at some point probably the earthen pot is more eco-friendly at all times.
Yeah, it appears so.
So because I'm not finding earthen pots today in the market. One of the reasons is they say that this is more, all the grow bag options are becoming more popular. More people purchase them, and they're not purchasing the earthen flower pots. So even if I want earthen flower pots, I'm not able to.
Yeah, that is
Seems
like
we are biasing, people, but many people are thinking it's doing a lot of good.
what shifting towards this synthetic materials.
Synthetic material. Synthetic material, they sometimes they recycle all this, even paint cans and everything. So even I used a few paint cans, punched holes. But now I'm thinking maybe I'm not doing good for the environment.
No, it's not like that. Actually, what Professor Dubey often says is that these synthetic materials, they themselves, if we talk about packaging and this kind of stuff, they themselves are not environmentally dangerous because itself they have very help. They can be very helpful for the environment if we actually make use of their innate properties. Like it doesn't degrade if we keep on using them again and again and again. Rather, we can avoid buying more clay pots, keep on mining more earth, more such burning of clay. We can actually avoid them if we judiciously use the synthetic
Huh.
packaging
That is
materials.
what I'm coming to. See, one thing is because the clay pots are not in usage, because they fear more topsoil will be used for making them.
Yeah, so it is basically the issue here is more of a solid waste
If we give
collection and
back to the
management.
soil, that should not be an issue. If we teach people to give back to the soil, then the problem is not you having the clay pots. The problem is not giving back to the soil.
No, in fact, even if you give it back to the soil, like you can throw it
No, we are
somewhere.
not making the soil.
No, actually, here if you compare both of them, you can see that the major issue is in the solid waste collection and then its management. So when we try to collect these things go into the waste stream very quickly, and whenever we try to collect them, then a hell amount of it gets leaked into the environment. So this leakage is where the issue is. The material itself, we can't actually say that it is environmentally dangerous. The dangerous is how we are handling that particular material.
So in that case, why I'm saying is, if I use a paint cans, punch holes. Yeah, after some time it is becoming brittle.
Yeah.
It is, and sometimes in powder form.
Hmm.
It is very difficult to recover that powdery debris.
The paint can, if it is getting brittle, you can like if there is
Many
a
people are many people are reusing paint cans for growing plants on the terrace in the garden,
hmm.
and we are all thinking it's doing a good thing, but these brittle portions might become microplastics, and which is very difficult to, they can get into the soil, water, and
Yeah,
it's
that
very
is
difficult to
another issue.
recover. So it gets into the food chain, and now there are articles where the microplastic is present even in the breast milk.
Yeah.
So that's the latest research. So what I'm thinking is whether all we are doing something, thinking it is doing good for the environment, but it may
Yeah.
not necessarily end up that
Yeah, that is why actually people have to recognize like there should be a system that should recognize a material and its entire properties. Like if you are using something for a certain purpose, it can be used like a plastic bottle is that it can be used. We are keep on drinking in the same plastic bottle, then the microplastics they leach out of it and then in just our body. So there should be a period like that is why we often say that these 10, 20 rupees bottles we should not keep on using them again and again and especially not keep them out in the sun with water because it is the plastics leach out of them more easily as compared to other materials. So these things have to be made very clear before using anything for any particular purpose.
even these concrete pots, if you look at the cement recycling, that is also costly,
Yeah, that is
and
currently costly.
it will go into the construction and demolition,
Yeah,
and it will sit there like a duck for a long time. So
true.
if you look at this example, you cannot apply this to all examples. I agree with what you said. In cases like the mobile phone and other products, we do need to spend energy and time and effort to recover the material. But in cases like this, where people are involved in day-to-day usage of common materials, and where we have options, natural options, even that is being discarded in favor of other things. So
Yeah,
maybe making a mistake.
yeah, that can be true. We need to like exactly go into the details and precisely see.
So
Yeah, true
I
that that can
whether
be
we
done.
can do an LCA for this.
Sorry, come again?
So we can do an LCA for this as a case study,
Yeah, that can be done.
and
Like
then compare the impact.
yeah, this can be done. But the major challenge in here is collecting the data in all those kind of stuff. So
Hmm.
that data collection phase, we can do such studies. You can see into various literatures or do surveys also. These things can be done. Already there are various open source softwares. They can be very helpful for getting a initial at least overview of what is happening exactly.
Mm. Mm. Because I did talk about the individual contributions
Yeah.
the last week, and I have sent a link today.
Yeah, I just saw that link. This is regarding GDP is the wrong tool for measuring what matters. In this one.
I actually posted a few questions on the electronic waste management discussion forum regarding the modeling of individual contributions.
Okay. So I
Um,
will actually I don't look into that particular course. I will let others know who are taking care of that.
Actually, yesterday we had a live discussion forum, but
Okay.
I'm not sure if I was on the live discussion forum yesterday on that course, and maybe Professor Rajesh Kumar Dubey did not touch upon these questions, but I just
No, if
uh,
there is a live session, he is open to receive any questions. He likes to get questions on different aspects. You can ask him.
Maybe the TA did not forward it to him, or they thought these were general questions. So
How
I'm not.
how does it go during those live sessions? Is there some TA attending to those live sessions, or is it
Actually, he knew because I do tend to ask such questions. But I've been taking his courses for the past 3 4 years, and he knows that I have spoken about these issues earlier,
okay?
and probably. But I thought about the modeling of these individual contributions only recently. I had this idea, so I thought, okay, I, I mentioned in the course, but it wasn't addressed there.
Actually, it
So
is
maybe,
better like if you have these particular queries, it is better if you mail directly to Professor Dubey. Like
okay.
because it will be better that way.
Mm,
I think last time I already shared his email ID in this, or you can get that from IIT Kharagpur website. It is already
okay.
there. You can directly
Okay.
mail him, and it is better to get an answer like that.
Okay. So I didn't want to repeat the same question in this discussion forum, because if he had already gone through that, so I did not. But probably I'll try posting it again, because I use the case study for the neem infused geyser water description.
Okay, I will
It
let
was
the team who is looking to that know that to address this question, maybe via personal contacting you or via discussion forum, whatever suits them.
mm, because I will extend that to a group area. The example I gave. So what I wanted to do is model the individual contribution and extend it to a group, and then from that to a sample population, and that to a larger population.
Yeah, you
So
explained something like that last time
something
also.
like that.
Did you
And
mail
also,
to Professor Dubey regarding that?
I posted that to the discussion forum,
Oh,
the electronic waste management discussion forum.
actually, he is most of the times he is a bit busy. So TAs they usually I think look into the discussion forum or this live sessions most of the time. So if you like you last time also you suggested that you have some particular ideas. If you want to work on them, particularly do some work on them, then it is better to directly contact him. He will be much more approachable like that.
Mm. Because why I ask is because we have, we live in an apartment, so it's a small place, and we have these common uh, the bathroom tile usage problems, but they use a lot of acid wash on the floors, and it causes grouting problems.
Okay.
So we have been recommending, and this is from the engineer who fixes the grouting problems itself. Where he says this is not required. You ask people to not use them so very regularly and leave it overnight. Just a 15 minute, once in 15 days, 15 minutes of um, diluted bleaching powder will do to clean the bathroom.
Okay.
But so this was also a suggestion which this option works very well in our bathroom, and we have people, but our ceiling has seepage problems because the person in the top floor is using acid wash almost daily, so it affects the building stability also.
Yeah,
So
this can be a good topic for study also if something like that
for
was
as a case study where the science contributions can enhance the technological
definite.
concepts. So that can be accounted for, and it also affects our STP maintenance also, because they people keep, because they want a simple. You have options. It's just that we need to. So I thought, maybe I felt they thought it was a general question, and then they let it pass.
No, whatever you told that is really true. Like you said it correctly. I think
So
you
maybe
raised the same question in the discussion forum as
put
well.
in the, is it okay to put that in the discussion, in this discussion forum again, and
No, no, actually, ideally this is meant to for that area, so people are
mm,
taking care of that in that particular course. Otherwise, if you
okay.
have like some case study related ideas, that is where you should rather communicate individually to Professor Dubey rather than putting it in the discussion forum because he will
Okay.
be more interested in that way.
So I thought, from discussing with you, I thought this is a reasonably good. way to model individual contributions, extend it to group contributions, and then extend it to a larger population.
Yeah.
So I mean, wherever possible, we can do that.
Yeah, that is why I'm saying that if you can take
And we can that feedback can be given to the economists to model things better.
definitely, if you can prepare like fix a meeting with Professor Dubey and pitch it this idea to them, then he can share this with his team members and maybe there can be some collaborative work that can be done in this regard.
Okay.
So, but for that we need to first take the permission from him
Okay.
since he's running this course and he also works actively in such areas. So it
Mm,
is better to first ask him that regarding that.
okay. Okay. Thank you.
Well,
So, one more thing in the lecture notes,
yes.
second week lecture notes, you don't have the first 4 days slides. You only have the fifth, the from sixth to ninth lecture. It
Uh,
is not the
which particular lecture notes?
second week's
Week
lecture notes.
two lecture notes, and for this particular course, right?
Yeah, you don't have the lecture notes from sixth to ninth.
Sixth to ninth, these slides are missing.
Yeah.
Okay.
So lecture, they are missing in the lecture notes. Only the last lecture 10 notes are available in the second week's lecture notes.
Fine, just let me just cross check that.
That has been put up in the discussion forum several times.
Okay, so discussion forum, it is basically a Gmail group, right? There are few questions.
If you go to the lecture notes of the second week,
Le-
only the lecture 10 is there. In the consolidated lecture notes,
Second week, right? In second
second
week,
week,
lecture materials, then lecture materials
only
for
the
week.
10th lecture is available.
Okay, and it is available only, yeah, lecture 10 is available. So this entire set of 25 pages, these are only lecture 10.
Mm.
Okay. Um, okay, fine. So rest from 6 to 9, these are not available. Okay, fine. I will let them know this one. Week 2. Okay. Fine. Yeah, I will let them know about these particular points and we'll try to add them.
So I've sent a couple more questions in the discussion forum, which I haven't received a reply so far.
Like, what is
It has,
your ID? I cannot see your, by which I,
it is GAIAS gaiasyoga.email at
Gaia,
gmail.com. Yoga
GAIASYU.
Yes, yoga yoga dot email at gmail.com.
Can you verify whether this is your Gmail ID? I I
Yeah,
have this one, right?
yeah, yeah.
So one of the question is that why is BUD and COD, one is 30 milligram per liter and one is 150 milligrams per liter? They are different.
Mm, mm,
So its answer is that usually in most of the cases, COD is always greater than BOD. So in BOD it is biochemical oxygen demand. So the oxygen required only for biochemical degradation of the materials, those are considered. Whatever contaminants or chemicals are there in our water. So that is why it will be lower. While to calculate this COD, we use potassium dichromate. It is one of the strongest oxidizing agents, so it will consume even more oxygen. So that is why when we are chemically checking the oxygen demand, it will be much more higher than this BOD. So when we set this disposal standard limits, discharge limits, BOD is lower and COD is subsequently higher than that because that is to take care of the higher values of COD.
but these are discharge limits, right?
Yeah, discharge, for example, if you say sewage, like
Mm,
if I discharge sewage into the water, the raw sewage, it has a COD of around 400, 500, it can go up to 700 also. But its COD will be, sorry, its BOD will be lower. It will be around 200, 300. So if you want to set, if you are judging a certain thing in terms of BOD, you have to also take care of the COD also because there can be certain chemicals there that cannot
mm.
be biodegradable, but those are there. So the COD take care of those recalcitrant chemicals which cannot be biodegraded. So that is why COD
What I'm
takes
trying
care.
to say is, shouldn't we have lower discharge limits?
Yeah, there is
before
actually
into
NGT.
the surface water.
No, there is no like, yeah, ideally we should have,
Why
but
is the chemical concentration allowed to be this high in that case?
sorry, can you come again?
This is see, then we are letting out more chemicals into the surface water, right?
Yeah, anyways, if you are seeing 30 milligram and 150 milligram per liter limits, anyways, whatever truly goes into the water, it can be 2x or 3x of it. These limits are mostly to push people and to impose them, like you have to follow these standards, and practically these things are scarcely happening. A few years back, I think NGT they tried to bring down this limit to 10 milligram per liter, this BOD1. So then there was again another question that people are not even able to reach this 30 milligram per liter discharge standards. How, like, what will be the point of setting 10 unless and until you really penalize people and you like actively work on this particular aspect? So there should be, ideally, there should be low discharge limits, but whether at all these will be effective or not, it is still a question mark.
Okay.
Let me see another. Okay, one was customizing this course for general public. This 10% energy rule related. Okay, this was answered. Participation.
And there is one on alkalinity, which
Yeah.
was related to question assignment. mm, I think two or let me wherein the options were given as calcium, carbonate ions, bicarbonate ions.
Yeah. Like there is a
Calcium.
question, please.
I'm just trying to find. I think assignment two. I think what determines the alkalinity of a liquid. So I think it was given the negative ions as well as calcium ion.
Yeah.
But the calcium ion was not included. So my question was, why is it not? Because although as the right answer,
What was the question? Like which ions or what components they leads to alkalinity? One of them was
one
carbonates, bicarbonates. Then other two.
the calcium ion, and I think
This
there was
is
some other I'm
week.
trying to
This
assign
is
to it.
week assignment 2, question number 13. Assignment 2, question number 13 is which of the following ions they cause alkalinity? There is a carbonate and then there is a calcium. So yeah, both of them should be correct. Like carbonate can also and calcium can also lead to hardness.
But anyway, in the
Actually, why carbonate? Because whenever we discuss about this alkalinity, no, this is regarding alkalinity. It is not hardness. So alkalinity will be caused by these ions, no? Calcium, no, calcium can also cause alkalinity. It's true. This one, something about- Yeah, alkalinity is basically whenever we discuss about alkalinity is carbonate or this bicarbonates, we talk about that. While discussing alkalinity, we talk about carbonates, bicarbonates, and OH. These three things they contribute to alkalinity, not calcium. Like when we actually calculate the alkalinity by different things, carbonate, bicarbonate, and OH, negative ions. So calcium is not the correct answer.
but calcium combines with.
Yeah, but when we actually calculate alkalinity, calcium can combine with carbonate, but that is will be the property of that carbonate. But if we actually look into the equations, how we calculate alkalinity, that takes into account this amount of carbonate ions, their concentration, bicarbonate, and that hydroxyl ion. These three things.
Okay, okay. Oh, so for hardness, it will be the multivalent cations.
Yeah, for hardness it will be that.
Okay. In some of the slides, there are some typos.
Okay, if something is there that is really creating any particular issue, because if there are many slides, then you can either list them to me, I can forward it to the team. Otherwise,
Okay.
if there is something that is really not making any sense due to a particular typo, then you can point that
For
out as well.
example, aerobic digestion and anaerobic digestion both are given the same
Sorry, come again. Anaerobic and aerobic both are given the same.
title.
Okay.
Aerobic.
Can
So
you
of this,
specify the slide number and which lecture?
I will put it in the discussion forum.
Yeah, that will be better.
And there are some other typos as well in, in the lecture slides of week 2.
Yeah, it will be better if you can this, especially the serious one where both
The
of
lecture
aerobic and
slides, yeah, I will compile them and forward it
yeah, that
to
will
the
be helpful.
discussion. I think that's about the questions from my side.
Okay.
Thank you very much, sir.
Well, you can leave the session if you want.
Okay.
बचा 7 मिनट।